Hello, grade 7s. Today what I want to do is just clarify some of the confusion surrounding section 8.4 of your Nelson workbook. That is solving equations by inspection. That's on page 84. So the goal of this section is to write equations and then to solve them through inspection. The most important definition that you'll need to know for this section is that of an equation. And that can also be found on page 84 of the Nelson workbook. It states that an equation is a mathematical statement in which the value on the left side of the equal sign is the same as the value on the right side of the equal sign. So what does that mean? If we look at a numerical representation of an equation, that's this here. This entire, and I'll just use a different color so you can see it a little bit better. This entire statement, 5x plus 3 equals 13, is your equation. Okay, so the left side of the equation, which is represented here, 5x plus 3, has to equal the same number on the right side of the equation, which is 13 here. Again, 5x plus 3 is equal or equivalent to 13. So how do we prove that? Because we don't know what x is. X is known as a variable. What a variable means, it just means it's an unknown number. And really, that's what we're trying to find out here today in this section. What is x? Now, a variable can be represented by any letter. It doesn't necessarily have to be x, but for this particular example, it is x. So, when we're trying to solve for this equation, what we're really trying to do is solve for x. What is x? How do we do that? So, the way we start is we need to remove the numbers from this left side of the equation and transfer it over to the right side. So that at the end we're left with just x equals a certain number, and that of course is what x will be. So let me just show you. It's probably easier for you to understand what I'm saying if I demonstrate it. And if there are any more confusions after I've demonstrated, you could always post your questions to the Google Classroom. So here we have 5x plus 3 equals 13. So the first thing I want to do is I want to remove this 3 from the left side of the equation. But there's a rule. Whatever I do to the left side of the equation, I have to do to the right side. So following that rule, if I have 5x plus 3, so I haven't changed anything so far, and I want to remove that 3, making it 0, how would I do that? 5x plus 3. To get rid of this 3, since this is a positive 3, I need to add in a negative 3 here. By adding in a negative 3 there, what I essentially did is, forgetting about the 5x for a second, is I have plus 3 minus 3, which equals 0. So that cancels both of these out. So now there's no more 3 on the left side of the equation. But remember what I said earlier? What I do on the left side, I have to do on the right side. So because I added a negative 3 on the left side, I also have to add a negative 3 on the right side. So if I rewrite this equation to simplify it, in other words, what simplify really means is just by actually calculating to reduce the amount of numbers on the left and right side of the equation, what I'm going to rewrite here is a simplified version of this. So now I have 5x plus 3 minus 3, as I said, cancel each other out, so I don't have to write anything there because that's just 0, equals 13 minus 3. 13 minus 3, if you can do it in your head or if you have a calculator nearby, is 10. So I'm now one step closer to having x by itself, or in other words, isolating for x. So 5x, and this I'm just going to do a little aside here because I know some of you might be confused with the way this is written as just 5x. What 5x really means, and I'm just going to write aside here. What 5x really means is 5, what this dot is representing is just a multiplication, 5 times x. So 5x basically means 5 times x. So if this is 5 times x, and I need to isolate for x, and remember I have to do the opposite of whatever it is, what is the opposite of multiplication? I'll give you a second to think. Okay, so if you said division, you're right. So the opposite of addition is subtraction, the opposite of multiplication is division, and vice versa. So to get rid of this 5x, or simply the 5, what I need to do is I need to divide by 5. So we said here 5 times x. I need to do the opposite of multiplication, so it's division. So I need to divide by what? Because I want x by itself and 5 is in front of it, I need to divide by 5. Now remember, what I do to the left side, again I have to do to the right, so equals 10 divided by 5. So now what you can see is the 5 and the 5, 5 divided by 5 is just 1, so these just cancel each other out. That leaves me with x equals 10 divided by 5, again, if you can do it in your head or if you have a calculator, either or, 10 divided by 5 is 2. So now you can see I've isolated for x, and what does x equal? In this particular equation, x equals 2. Now, if I'm not confident with my answer, I could always double check my work. How do I do that? All I have to do is I have to plug in x into the original equation. So, the original equation, I'm just going to put a dotted line here to separate. So if I want to check my work, I just rewrite the equation, 5x plus 3 equals 13. And I substitute 2 in for x, because that's what I found x to be. So 5, I'm going to put in brackets 2 here for my x. Remember, if they're side by side, that's like saying it's not 52, be careful, it's 5 times 2. Anytime you see a number beside a number in a bracket, that means multiplication. So 5 times 2 plus 3 equals 13. So now to simplify, 5 times 2, again, doing it in your head or on a calculator, 5 times 2, that's 10, plus 3 equals 13. 10 plus 3 is 13, which equals 13. Because both the number on the left side of the equation and the right side of the equation equal, I know that x equals 2 is the correct answer. Now, like anything else, I know this can be confusing, especially if this is the first time you've seen this type of work. But like anything else, with more and more practice, you'll get better and more confident. So please complete all the homework in the Nelson Workbook on page 84. And again, as always, if you have any questions, please post all your questions on the Google Classroom, and I'll get back to you as soon as I can. Thank you.